Good morning. All right, so we're going to take a look at a couple of these tasks. I'm going to start with task 2. So we're dealing with trigonometry here, and I've got a couple tasks. This one deals with the sine and cosine of complementary angles. Thinking back to complementary angles, when we've got two angles that add up to give you 90 degrees. So when we have a right triangle, the two angles that are not right are going to add up to 90. So let's take a look at part A here. So suppose that you have an angle A that is between 0 degrees and 90 degrees. It's a measure of an acute angle. It's the definition of acute, if it's more than 0 but less than 90. Draw a picture and explain why the sine of angle A is equal to the cosine of 90 degrees minus angle A. So that might be kind of intimidating, but let's start with a picture of a right triangle, because we know that A is acute. So right triangle, I know that A is acute. And then we'll just go B and C. So we're going to be talking about this little guy right here, that angle. All right, so picture done. So let's figure out how we can explain why this happens. And so we can start off with the different trigonometric ratios of A. So I'm hoping that last week's content helped you out with the sine ratio, the cosine ratio, and the tangent ratio. So let's get those out here. So just for remembering, I always use this mnemonic device, SOHCAHTOA. And what it does is it says that the sine is equal to the opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and that the tangent is equal to the opposite over adjacent. So, okay, we're going to take a look at sine, because that's what we've got going on right here. So the sine of A. If I look at the sine of this angle, I want to know the opposite value over the hypotenuse value. So the sine of A is going to be whatever the distance of BC is over the distance of AC. Okay. Since B is a right angle, we have a specific relationship now too. So that's piece 1, little information number 1. Information number 2 is that I know that when I add up these angles here, let's get another angle A plus angle B plus angle C. It's a triangle, so those need to add up to 180 degrees. So let's get that piece of information down here. Measure of angle A plus measure of angle C plus measure of angle B all add up to 180 degrees. So I can simplify this, right? We could subtract 90 from both sides. And then we're left with our complementary angles. Measure of angle A plus measure of angle C is equal to 90 degrees. All right, I'm going to move this for the sake of what we're trying to show here. If we go back up here, we're trying to get sine of A on one side and cosine of A on the other. So I'm going to move some things around here. I'm going to subtract angle A. Let's actually rewrite this as A plus measure of angle C equals 90 degrees. I'm going to subtract A from both sides. And I get measure of angle C equals 90 degrees minus A degrees. Okay. All right. So we're going to take the cosine of C, because that's what we're trying to get. And it's going to make sense in a moment, but cosine of C. So we're going to take the cosine of both sides. So before we do that, a little bit of clue. let's go purple on this, not so bold. What's the cosine of angle C? Well, cosine of angle C, so if I'm looking at this angle here, cosine of angle C says adjacent over hypotenuse. So the adjacent side over the hypotenuse. So the cosine of C is going to be BC over AC. So this is important information. I'm going to get rid of this for now. Cosine of angle C, we know that it's adjacent over hypotenuse. And so if I write out cosine of angle C, that means that if I take the cosine right here, I need to make sure I take the cosine right here. Okay? And we just decided that cosine of angle C is BC, its adjacent side over the hypotenuse, which is the cosine of 90 minus A. All right, so this piece of information is really important because what you'll notice is we started out with the sine of A. What do you notice about the ratios? Let's go pink because this is celebratory. What do you notice about the ratio here and here? BC over AC, BC over AC. I really hope that you see that those look the same. So what that means is that you can take the other sides of the equations and you can set those equal to each other. Okay, so sine of A equals cosine of 90 minus A. And if we go all the way back up to our step A, we've just explained why those two are equal to each other. Yay! Oh, geez. All right, so now we're going to work through this next one. This next one isn't too crazy. Part B, are there any angle measures such that 0 degrees is less than 8 is less than 9 degrees? So looking for another acute, such that sine of A is equal to cosine of A. And this is just working with the ratios. So let's get back to our hypothetical triangle. Hypothetical triangle, A, B, C. All right, and so I want to know when sine of A, so remember a little guy down here, when sine of A is equal to cosine of A. Well, my suggestion is to get the ratios of these and see what they really mean. So in the ratios of these, sine of A is opposite, so SOA, opposite over opposite over hypotenuse. So BC, BC over AC. And cosine of A is adjacent over hypotenuse, so AB over AC. So I'm hoping that you notice that the only distinguishing feature here is the numerator of these ratios. And so if we know that these values are the same, then the numerators must be the same. And we actually see that the denominators are the same. So when we write out all of this, we need BC and AB to be equal. So if that's the case, we're dealing with a triangle up here where this distance must be the same as this distance. And I'm hoping that you think back to, oh, that means it's an isosceles triangle, and it's a right triangle. So it's an isosceles right triangle. Triangle. When you have an isosceles triangle, not only are your sides congruent, but your angles are congruent. And that's something we learned way long ago. So if the angles are congruent, that means angle A plus angle C must add up to 90. So two numbers that are the same that add up to 90 are going to be 45 degrees. So this triangle ends up being an isosceles right triangle where A is 45 degrees. I guess we could write that as the measure of angle A. And that concludes task 2. So let me know if you have questions, and I will post this video shortly.